Hello guys, good evening everyone. Welcome to the session. Welcome to the GATE previous year questions discussions once again. Hello guys, good evening everyone. Welcome to... All right. Okay, so let's get started guys. And yesterday we discussed the previous year questions of EMT only, but that was for electronics branch. Today, for the years of 2021, 22, 23, that is last 3 years, we are discussing EMFT questions of the EE branch, right? Of the EE branch, right, G? Okay, of the EE branch. Okay, now of course, EE topics that is restricted to electricity and magnetism, they are common for EC also. So this session can be beneficial for EE, EC as well as instrumentation students. Okay. Okay, so let's get started guys. This is a regular introduction about me. So guys, for the PDF of today's class, okay, whatever we discuss, the question, the solution, the concepts, okay, and all of the PDFs of my classes, updates about my classes, important concepts, important updates about the upcoming vacancies, PSUs notifications, and etc. You can be linked in my Telegram to be connected. Okay, now let's get started with the first question here. Okay, now let's get started with the first question coming up here. Okay, a 1 microcoulomb point charge is held at the origin of a Cartesian coordinate system. If a second point charge of 10 microcoulomb is moved from 0, 10, 0 to 5, 5, 5 and subsequently to 5, 0, 0, then the total work done is how much? Then the total work done is how much? See, potential is work done per unit charge. Okay, so how do you calculate the work done in moving a particular charge? It is given by Q into V. Okay, Q into VAB. Okay, now, okay, let's say this is A and let's say this is B. We all know that VAB, the potential, okay, is independent of the path. Okay, the potential difference between any 2 points is independent of the path because the electrostatic field, it's a static field. This field is only due to a point charge, that is static in nature. So electrostatic field is conservative in nature. Electrostatic field is conservative in nature, and that is why its line integral, which will give you the potential, will be independent of the path. Okay, so you only need the initial point and final point. Okay, Q, for which you are calculating the work done. So you are calculating the work done as 10 microcoulomb charge. Okay, now VAB. Okay, this can be broken as, what is VAB? VB minus VA. What is the potential due to point charge? Okay, let's get moving ahead. So W is equal to Q into VB minus VA, and that will be equal to Q into VB. What is the potential due to point charge? It is simply given by the formula KQ by R. It is simply given by the formula KQ by R. Q is the charge due to which potential is being calculated. So be very careful here. K into Q dash, let me call it as Q dash, okay, divided by R1, okay, divided by what? Divided by RB, sorry, minus K. Q dash is divided by RA. Now Q dash is the source charge. Q dash will be 1 microcoulomb because that is the point charge that is held at the origin and that is producing the field at the other points. Clear? Due to the field of this, okay, we are calculating the work done in moving a particular charge, that is a 10 microcoulomb. That is a 10 microcoulomb. It's a simple 1 mark question of 2021. So this is going to be 1 microcoulomb. Okay, now K, as we all know, in free space is 1 upon 4 pi epsilon naught, whose value you can directly put 9 into 10 power 9. Okay, 9 into 10 power 9. Now what is RB and RA, dear? What is the RB and RA? So if you have a look into the very simple picture, okay, this is the x-axis, this is the y-axis. The point A is only on the y-axis, that is the 0, 10, 0. That is the point A on the y-axis, 0, 10, 0. And the point B is 5, 0, 0, that is only on the x-axis. So that is why I am only drawing the xy plane. Okay, and this is what? This is what is your Q dash charge, which is the 1 microcoulomb. Okay, so what is the distance of the point B? Okay, what is the distance of the point B? Okay, from the source charge, this is known as RB, and that is equal to how much? 5 units. What is the distance of the A point from the source charge, that is known as RA, and RA is equal to 10 units. From origin to 0, 10, 0, that is 10 units. Only you have to place the values here. Okay, so how much will be the work done? Now start placing the value. This Q is 10 microcoulomb, 10 into 10 power minus 6, multiplied by, okay, what you can do is you can take the KQ dash common actually. Okay, so Q into KQ dash common, 1 upon RB minus 1 upon RA. Okay, that's it. Okay, so let's move forward. Okay, the work done will be equal to 10 microcoulomb into K, 9 into 10 power 9, into the Q dash, which is just the 1 microcoulomb, okay, into 1 upon RB, into 1 upon RB. The distance of the point B is 10, it is 5. So 1 upon 5 minus 1 upon RA. RA is equal to the 10. RA is equal to the 10. Okay, so 10 power minus 12. So 9 and then 10 power 10 cancel to 10 power minus 2 into 0.2 minus 0.1. Okay, so the answer is 9 into 10 power minus 2 into further 0.1. Okay, 0.1 is also 10 power minus 1. So finally this is 9 into 10 power minus 3 joules. So final work done can be written as 9 millijoules. What is the unit in which they are expecting the answer? Okay, they are also expecting in millijoules. So in terms of millijoules, your answer is 9. The correct answer is 9 millijoules. Okay? The very correct answer is 9 millijoules. Next, consider a large parallel plate capacitor. Okay, the gap D between the two plates is filled entirely with the dielectric slab of relative permittivity epsilon R. Okay, which is 5 actually, it's missing here. The plates are initially charged to a potential difference of V volts and then disconnected from the source. If the dielectric slab is pulled out completely, then the ratio of the new electric field in the gap to the original electric field E1. Okay, now for a parallel plate capacitor, okay, for a parallel plate capacitor, electric field is simply equal to the potential difference between the plates divided by the plate separation. It is simply V by D, a uniform field V by D. But, okay, but what they're telling, it is charged to a potential of V and then disconnected from the source. And then it is going to be disconnected from the source. So there cannot be any more gain or loss of the charge. So, you know, if we place this, we also know that Q is equal to CV. Okay, the charge is C into V. So putting it in the capacitance formula, you can also write it as Q upon CD. Okay, you can write it as Q upon CD. But what is the value for C? C is epsilon S by D. For the parallel plate capacitor, capacitance is epsilon S by D. Very good evening, Ashok. Okay, so what is going to be C into D then? Okay, that is simply epsilon S. Okay, so eventually, dear, what is the electric field? Okay, is Q upon epsilon S. Q is going to remain constant because it is disconnected from the source, and also S, the plate area, remains constant. So in a sense, the field strength is inversely proportional to the permittivity. Now, what is the situation? First, it is filled with a dielectric slab whose relative permittivity is 5. Okay, and then the dielectric slab is pulled out completely. Then the new electric field is E2. Okay, so what is E2 by E1? Because inversely proportional, so that is epsilon 1 upon epsilon 2. Inverse chalega. Epsilon 1 is epsilon naught. Sorry, epsilon 1 is equal to 5 epsilon naught. And now the dielectric slab is pulled out completely. If it is pulled out completely, what is there inside? Nothing, vacuum, air. So the permittivity will be epsilon naught. Okay, so answer is 5 by 1. Okay, so what is the ratio E2 by E1 is simply numerical answer type data 5. Okay, as a numerical answer type data, I will place the answer as 5 units. Okay? My final correct answer is equal to the 5 units. Then that's it. Next question. Okay, again 21 EE 1 mark simple question. 2022 EE 2 marks good question. This is a good question. Come to this one. Okay, as shown in the figure below, two concentric conducting spherical shells centered at r equal to 0 and having the radii r equal to c, r equal to d are maintained at potential such that the potential at r equal to c is V1 and the potential at r equal to d is V2. Assume that VR depends only on r, where r is the radial distance. Okay, very clearly mentioned. Okay, VR depends only on the R anyways for spherical charge distribution. Okay, VR or electric field also will depend only on R for spherical charge distribution. That also you must know, but they have mentioned it. Okay, where R is the radial distance. What is the expression for that VR in the region between R and C? Because VR depends only on R. Okay, the potential, which is a potential of R, it is only a function of R. Okay, to solve this, we are going to use the Laplace equation. Okay, we are going to use the Laplace equation del square V equal to 0. Okay, del square V equal to 0. And as I mentioned, V is VR. Correct answer, Ashok, for the previous one. Okay, because it is only dependent on R. Okay, so what is the Laplacian equation? Okay, first term, that is the connected to R, del by del R term, that is given by, okay, so your del square V, you can only consider the part 1 upon R square del by del R of R del V by del R. Okay, of R del V by del of R square del V by del R, sorry. And this is equal to what? This is equal to 0. The potential term is 0. Okay, the del square V is 0, Laplace equation. Now, the derivative of some term is equal to 0. Derivative of something is 0, that means that particular term R square del V by del R can be some constant K. Can be some constant K, correct. So, what is the value of del V by del R? Del V by del R is equal to K by R square. So, when you integrate this, what is the V? When you integrate, 1 upon R square integral is minus 1 by R. 1 upon R square integral is minus 1 by R. But because you are integrating one more constant of integration, so suppose isko K1 bola, so I add a constant of integration, suppose that is the K2. Okay, so what is the potential function that you are getting here? It can be written as minus K1 by R plus K2. But now what is K1, K2? The constant. Okay, when the medium itself contains some charge. Okay, what is Poisson equation, Ashok? Del square V equal to minus rho V by epsilon. Okay, where rho V is the volume charge density of the medium. So if there is another source, okay, due to which there is some charge in the medium, there is some volume charge density of the medium, then we go for Poisson. For source free, it is Laplace. Okay, so that is the reason. Okay, yeah, good evening, dreamer. So what is K1, K2? For that, boundary conditions are given. The potential at R equal to D is V2 and the potential at R equal to C is equal to the V1. Okay. Okay, you are given at R equal to C, the potential is V1. Okay, तो इसको use कर लेते हैं. Okay, substituting this, I have V1 is equal to minus K1 by C plus the K2. Okay, that is the first condition given. Similarly, at the radius of D, okay, the potential is equal to V2. Okay, so if I substitute this, I have the V2 which is equal to minus K1 is divided by D plus the K2. That is my second equation. That is my second equation. Okay, so I can easily get the value of K2 from here if I just subtract the first and second equation. V1 minus V2, okay, will be equal to what? If I subtract these two, minus K1, 1 by C minus 1 by D. Okay, or I can say V1 minus V2 is equal to minus K1 into D minus C divided by CD. So dear, what should be the value for K1? K1 will become CD into V2 minus V1 divided by D minus C. That is the value for K1. Okay, now putting it any one of equation, putting it in any one of the equations, suppose let me come to the equation number 1. So V1 is equal to minus K1 by C plus K2. So V1 is equal to, thoda sa calculative hai, okay, going forward, is equal to minus K1 by C, okay, minus K1 by C. So when you divide by C, okay, you divide by C, you are going to be left with D into V2 minus V1 is divided by D minus C. Is divided by D minus C. C cancel ho chuka hai. Okay, plus the term K2. And so now from here we have to figure out what should be the K2. Okay, bringing it on the other side. So V1D minus V1C. Okay, minus V2D minus minus plus V1D. Okay, whole divided by D minus C. So ये कितना होगा, V1D is going to be cancelled, but यहाँ पे नहीं हुआ, one of the term has to be cancelled, or just sorry, V1D minus V1C plus minus dV2 plus V1D. What is the error that is happening here? K1 by C, so only D is left, V2 minus V1 by D minus C, and that is actually plus, sorry, okay, ये plus किया है मैंने, sorry, that is plus on the other side ना, तो plus dV2 minus dV1, okay, so correct, minus dV1 will get cancelled, so I am left with the V2D minus V1C is divided by D minus C. That's it. Now the complete solution is done. Okay, so what is the potential? It is given by minus K1 by C. Okay, it is given by minus K1 by C. Okay, again minus K1 by C, so you are left with D. Okay, the potential minus K1 by R. Okay, minus K1 by R, the general solution. Okay, so that is minus CD, V2 minus V1 by D minus C into R plus the K2 term, where this is the K2 term, V2D minus V1C upon D minus C. Okay. Option doesn't start with minus, of course, तो minus को हटा देंगे यहाँ से, so you can write it as V1 minus V2, CD into, earlier था V2 minus V1, so I will write it as V1 minus V2. That's what it is. So my correct answer is, of course, everything is matching with the option number B. Finally, V1 minus V2 tha. Correct, option number B. That's it. That's it, simple one. That is the option number B. We shall now move ahead to the next question. Okay, so guys, like before I go to the next question, let me just tell you that like you are practicing here on the YouTube, you can also get several practice sessions live as well as recorded on the BYJU'S exam prep app. Also, several practice quizzes, free practice quizzes are available daily. At least you can try to attempt one quiz of maybe your favorite topic and see and try to compete with the other fellow aspirants. Okay, more and more quiz you participate, your name will pop up in the leaderboard, so you can see where do you stand, and lots of other study notes and many activities can be done on the app as well, BYJU'S exam prep app. So download it from the Google Play Store. Also, there is a link in the description of the same video. If you want, you can directly download using the link. Okay. Also guys, the coming Wednesday, 4th of October. The coming Wednesday, 4th of October, 7:30 p.m. Okay, I bring to you a free live interactive workshop, 7 prime qualities to be a topper in GATE 2024. Yes, let's target GATE 2024. And what are the 7 prime qualities, okay, that reflect, okay, that you can be a topper? We'll talk about that this Wednesday at 7:30 p.m. 4th October. Next question, guys. Next question. 1 coulomb of point charge with a uniform velocity 10x enters the region x greater than 0 having the magnetic flux density B given to you. What is the magnitude of force on the charge at x equal to 0 plus? Do it up simply. Okay, what is the formula you use here? Okay, there's only the magnetostatic force here. Okay, the magnetostatic force on any charge is given by Q into U cross B, where U is the velocity, B is the flux density, we simply call it as magnetic field as well, and Q is the charge onto which you are calculating the field. Okay, and then you need only the magnitude of the force. Quickly do it up, guys. Okay, do it up. This time aptitude, next weekend I will take up something on maths. Okay, Ashok? Just do it up, guys, and allow me just 1 minute. Yes guys, sorry for interruption. Yeah, let's continue. Okay, yeah. Anybody with the answer? Simple question only. The Fm is equal to Q into U cross B. So the charge, okay, onto which you are calculating the force is simply 1. The velocity is 10x direction, so that is 10 ax simply. That is simply the 10 ax. Okay, cross product with B, and that is known as 10y ax plus 10x ay plus 10 az. Okay, Tesla, the flux density, Weber per square meter. Okay, okay, dreamer, yes. So now x cross x is 0. Okay, next term 10 cross 10, 100, 100x, but x cross y will be z, 100x az. Next is 10 cross 10, 100, but x cross z will be minus y, so minus 100 ay. That is the actual force, but at x equal to 0 plus. So see, what is the force that I have obtained is given by 100x az minus 100 ay. For x tending to 0 plus, the Fm will be just minus 100 ay actually. Okay, because x tending to 0, so this is the first term is 0 itself. They are only asking the magnitude of the force. To convert it into a numerical type question, the magnitude of this force will be the plus 100. Will be the plus 100. That's the correct answer. The magnitude of the force, again 21 1 mark, simple question. Okay, the magnitude of the force is 100. Okay. Okay, 23 2 marks double question. 2023 2 marks double question. An infinite surface, okay, of linear current density K is equal to 5 AX ampere per meter exists on the XY plane as shown in the figure. The magnitude of the magnetic field intensity at the point 111 due to surface current. Okay, due to surface current. Now due to the surface current, what is the magnetic field? Okay, due to the surface current, magnetic field is given by the expression that is half of K cross, that is simply half of K cross A n cap. Half of K cross A n cap, where K is the surface density and A n cap is the unit vector normal from the sheet to the point of observation. So where is the sheet? Sheet is in XY plane and your point of observation is 111. What can be your point of observation? The sheet is in XY plane. The point of observation is at Z equal to 1. Okay. Is at Z equal to 1. देखो इसको ऐसे समझो ना. Suppose if I take Z equal to 0 for a moment. If I take Z equal to 0, you are at 1 1. So 1 1 means within the XY plane. Okay. You can take the point 1 1, X equal to 1 and Y equal to 1. But Z also equal to 1. मतलब you will raise up. Z is the vertical axis here. So you will raise up. Okay. At some point here. That means with respect to sheet, okay, what is the unit normal vector? With respect to the sheet, what is going to be the unit normal vector? Can you tell me? With respect to the sheet, what is going to be the unit normal vector? That is going to be pointing towards the Z direction. So this is going to be half. The K is 5AX. The unit normal vector will be Z. So answer is X cross Z is minus Y. So minus 2.5 AY. It's a simple question for 2 marks. Although EE was 2023 was a difficult paper, but this one was relatively very easy. So what is the magnitude of this H? Okay, what is the magnitude of the magnetic field intensity H? And that is simply 2.5. That is simply 2.5. Simple one. 2.5 ampere per meter. Done? Eh? 2.5 ampere per meter. Because you are in the XY plane and you need the point of observation, that is 111. So at a particular height above, इसको ऐसे समझ लीजिए. Okay, say this is the XY plane, this is Y, this is X. Okay, this is your sheet. Okay, but your point is somehow towards the 111. That is at a particular height. Suppose this is 111. Okay, so what you will do when you want to take the unit vector, okay, you will be traveling. Okay, this is the A n cap. Okay, and you are traveling towards Z axis. From the sheet to the 111 means you are traveling towards Z axis. Okay, so that is the A n cap. That is what is known as the A n cap. Right, dear? Next question. Here it is. Which one of the following vector function represents a magnetic field B? Okay, 2021 EE 1 mark, simple question again. Okay, what is one of the property of the magnetic field? As per the Maxwell's law, del dot B equal to the 0. The del dot B is equal to what? The del dot B is equal to the 0. Correct. Del dot B is equal to 0. Okay, so for option number A, when you take the del dot B, what is the del dot B, dear? General formula for del dot B. Divergence. For Cartesian coordinates, it is simple. All of them are Cartesian coordinates. The del by del x of the x component, del by del y of the y component, del by del z of the z component. So for the first one, del by del x of the x component will be 10. Del by del y of the y component will be 20. 20y का differentiation 20. 30z का differentiation 30. Minus 30 आएगा. So 10 plus 20 minus 30, 0. This is the one satisfying. It's a MCQ question. You can straight away mark option number A. Okay, but others also if you check, what is the del dot B? For others also if you check, differentiation of x, 10x, 10. Differentiation of 30z with y, 0. Differentiation of 20y with z, 0. Okay, so overall the answer is non-zero. Correct, Ashok? Correct. Third option. What is del dot B for the third option? Okay, differentiation of 10y with x, 0. Differentiation of 20x with y, वो भी 0. Differentiation of minus 10z with z, so that is minus 10. So overall answer is minus 10 but not equal to 0. Last option, differentiation of 10z with x, 0. 20y with y, 20. 30x with z, 0. So answer is 20, which is non-zero. That's what in MCQ questions are simple now, because if one option match, you need not check further. This is just for your clarity, I have checked. But if it is MSQ, you have to go through each and every option. Okay, A is the correct answer. Next question. If the magnetic field intensity in a conducting region is given by the expression x square I cap plus x square y square j cap plus x square y square z square k cap ampere per meter, what is the magnitude of the current density, okay, in ampere per square meter at x equal to 1, y equal to 2, z equal to 1? Basic Ampere's law question. Okay, basic Ampere's law question, 2022 EE 2 mark, simple question. Okay, it is the current density, which is the curl of the magnetic field intensity, and it is a Cartesian question. It is a Cartesian coordinate system, so it's going to be even simpler. Okay, so let's apply the formula for curl. Let us simply apply the formula for curl, del cross h, and that too in the Cartesian coordinates, and that is given by ax, ay, az, del by del x, del by del y, del by del z, and then the vector components. The components of the vector x square, y square, x square, y square, z square. X square, y square, x square, y square, z square. Okay, so now let's start it. Okay, let's start this. So with the ax cap, del by del y यहाँ पे लिया तो 2y, तो 2x square y z square. Del by del z of the other term will be 0. Minus ay, del by del x, 2x, y square z square fixed. Del by del z of x square, 0. Plus az, del by del x, again x square का derivative 2x, so 2x y square. Del by del y of x square, again 0. Partial derivatives keep in mind. Okay. So now, what is the current density? The current density is turning out to be 2. Directly value रखते हैं ना. Actually, they have put it into the numerical form, NAT form. Oh, sorry, MCQ here, but they are asking a numeric value 1, 2, and 1. Okay, at 1, 2, and 1. So at the coordinates, that is 1 and 2 and 1. What is going to be j? Okay, so 1 and 1 and 2. 2 2s are 4. 4ax minus 2 into 1 into 1, 2. But you get 2 square. 4 2s are 8. So minus 8ay. And plus again y square is there. So y square becomes 4. 2 4s are 8. That is 8az. 4ax minus 8ay plus 8az. Okay, that is the j. Okay, that is the j. So what is the magnitude? Again, they are only as the magnitude. So magnitude of the vector is square root of 4 square plus 8 square Okay, that will become square root of 128 plus 44, 144, and under root of 144 will be 12. This is the answer. The correct answer is option number B. It is 12. Simple question for 2 marks, I will say. Direct simple question for 2 marks. J is equal to del cross H. J is equal to what? Del cross H. A direct Ampere's law application. Okay. Next question. 2022 double E 1 mark. Now same year. Okay, similar question but little bit more better. ये 1 mark का है, ये थोड़ा better है. Previous one was 2 mark, direct simple. A long conducting cylinder having a radius B is placed along the Z axis. The current density is JAR cube. Okay, for the region R less than B, where R is a distance in the radial direction. What is the magnetic field intensity? Okay, now because it is a cylindrical wire, a long cylindrical, long conducting cylindrical. Okay, it has the current density JR cube in the Z direction. Since the current is in the Z direction, as per the right hand thumb rule. Okay, देखो, current is in the Z direction. Okay, if the current is in the Z direction, dear, this is the direction of current. As per the right hand thumb rule, the magnetic field will be in what direction? The current is in Z direction. Current density given hai, current nahi given hai, but that is in the Z direction. Okay. So current is flowing in the Z direction. Tell me the magnetic field will be in which direction? The magnetic field will be in the, as per right hand thumb rule, as per the right hand thumb rule, the magnetic field will be in the azimuthal direction A5. Okay, circular direction about Z axis. Circular direction about Z axis. Okay. Okay. So I can simply take that magnetic field H is having some phi component H phi A phi. It is only having the phi component. Okay. Acha. Now J is given to you. Can we apply the previous trick, previous question logic? Yes, we can apply. Rather than, you know, integrating and calculating the current and then applying the Ampere's law. Okay, that the integral H dot dl is equal to current enclosed. So that can be little bit more lengthy. But if you directly fix to the previous question concept, J is del cross H. But sir, H is not given. If H is given, I can calculate the curl and tell you the J. But J to given hai na. Acha, this is in cylindrical coordinates. Remember, I have taken it in the cylindrical coordinates. Whether you take the curl or whether you integrate, you have to take care of the coordinate systems. Okay, even when you are integrating H dot dl, you have to take care what dl is. Okay, otherwise everything will go wrong. Okay, so the curl formula in cylindrical coordinates is given by 1 upon rho, rho a rho, okay, rho a phi az, del by del rho, del by del phi, del by del z. Okay, then the vector components h rho, pehle formula likh diya, rho h phi and hz. This should be the formula actually, correct? This should be the formula actually. Okay. Chalo. So now this is equal to 1 upon rho. Okay. Now let me place the values actually. Now only phi component is there. Okay. Only the phi component is there. H phi which is unknown. In dono ko kar diya maine 0. Okay. So 1 upon rho. Okay. Then I have a rho. Dekho, del by del phi of 0. Del by del z of rho h phi 0. Because magnetic field is in the phi direction. It's a function of phi. And it's a function of what? Acha. It's in the phi direction, but this is going to be a function of what? It's going to be a function of rho. Because as you move away from the source, magnetic field will decrease. Okay. So this will be a function of rho. Ye yaad rakhna. Okay. So because del by del z of the rho term will be 0. Okay. Now next pe aa jayenge. Minus rho a phi. Del by del rho and del by del z of 0. Both are 0. Okay. Plus coming to the z term. Okay, del by del rho ये निकालना पड़ेगा, del by del rho of rho h phi minus 0, del by del phi of 0. Okay, that is what it is. That is the J. And now J is given to me. J is given to me. Okay. Achha, here they have taken the distance as r rather than rho. So we can convert everything to r. No problem. Okay. We can convert everything to the r actually. Let's call the cylindrical coordinates as rho phi z. Or better call it as r phi z. In the question they have used the parameter as r. So 1 upon r, this will become ar, this will become del by del r. Okay, and isko bhi likh denge r. Okay, and then here also let me replace all the terms properly. Sorry for a moment, ये हो गया 1 upon r, this is AR, okay, then okay, minus RA phi, okay, and then plus AZ del by del R of RH phi, okay. Now see, when you open up the bracket, when you are going to open up the bracket, J is given to you already. What is the J? अब उसको use कर लेंगे, JAR cube. What is the J? That is JAR cube AZ is equal to, and that is why solving the curl also you are only getting the Z component. Okay, solving the curl also you are only getting the Z component. So that is how much? That is AZ 1 upon R. 1 upon R, ये आएगा बाहर से 1 upon R del by del R of RH phi. Del by del R of RH phi. Only this is left. So both are in the Z direction. Let us compare the magnitudes. Okay, AZ को हटा देते हैं. Okay, so I have JAR cube. Okay, better. ये differential equation बन गया. Del by del R of RH phi is equal to JA. JA is a constant and then R को, इस R को अदर shift किया तो R power 4. Okay, differentiate this. Open करेंगे इसको. So when I open it up, okay, सबसे पहले R constant, differentiation of H phi. Del H phi by del R. Plus, okay, H phi constant, del R by del R will be 1. Is equal to JA R power 4. इसको थोड़ा सा rearrange किया तो you are getting a differential equation. Del H phi by del R, okay, plus 1 by R H phi is equal to JA R cube. I've divided by R throughout. You know what is this equation? You know what is this equation? This is of the form dy by dx, dy by dx, इसको x माना, plus 1 by x into y, h phi means y, is equal to some constant ja into x cube. Okay, dy by dx, first order linear equation, plus py equal to q. dy by dx plus py equal to the q. Okay, so what is the integrating factor? E raised to the power integral p dx. E power integral 1 by x dx. 1 upon x का integral log x. E and log inverse of each other, they cancel. The integrating factor is x. So what is the solution then? What is the solution of this? The solution is given by y into integrating factor is equal to integration of q, that is jax cube, into if, that is x, dx plus c. Okay, so I have xy is equal to ja x power 4 integral x power 5 by 5, okay, plus c. Okay, so what is y actually? So y can be taken as ja x power 4 by 5 plus c by x. Plus c by x. Okay, now look into this. The current is a function of R. So if I take R equal to 0, what is the current density? 0. And if the current density is 0, that means the field also is 0. Okay, no current will produce no field. Okay, so we can simply put that. Isko dhyan dena. Okay, so now this y means what? This y means h phi actually, and that is given by ja. X kiski jagah aata? X is in place of R. It is a function of R. R power 4 by 5 plus c by R. But you can now use, okay, you can now use that at R equal to 0, the J is 0, so magnetic field should also be 0. Okay, magnetic field should also be 0. So 0 is equal to 0 plus C by R. Okay, but C by 0 can be infinity. C upon 0 can be infinity. But if you take C upon 0 infinity, left hand side, right hand side doesn't match. So the only possibility is C will be 0. You have to eliminate the C term. Okay, and then your H phi component is Ja R power 4 by 5. Complete magnetic field Ja R power 4 by 5 into A phi, if you want to write down with the direction as well. Ja R power 4 is divided by the 5. Okay, Ja R power 4 is divided by the 5. So option number C. Correct है जी. Done है. Gaurav, electromagnetic field theory. Yes, Ashok, C is the correct answer. This one is a good question for 1 mark. इसी का previous version देखोगे, similar question, similar concept, but that is 2 marks. That was very easy. So sometimes the questions, the marks also, sometimes it becomes unpredictable, not always. But ये 1 mark के लिए good question था. Even if you want to solve it by the regular Ampere's law, the integral form of Ampere's law. Okay, what is the integral form of the Ampere's law? Integral H dot dl is equal to current enclosed. Define a particular Amperian path, apply the line integral, calculate the current enclosed within that path by integrate by the surface integral of the current density vector. वहाँ पे integration वाला approach जाएगा. That is also okay, but ये भी एक approach मैंने present किया यहाँ पे आपको. Okay, so that also is applicable. That also is applicable. Okay. Done है जी. Okay, dear. So that's it. As you know, for doubly the number of questions in EMFT is of course lesser. Okay, yesterday took more time because EC का था. EC has a good weightage, doubly has a small weightage. But अभी हमने discuss किया. Okay, question based on current carrying conductor. So today's PCA PDF password that is striking to my mind is current. You will get the PDF of today's session with complete question and the solutions we discussed. But that is as always password protected. The password is going to be current, CURRENT. The current, CURRENT. Okay, you can use this password, okay, to access the PDF. Okay, in my Telegram. Also guys, the gate crash course, okay, for the complete syllabus coverage in the remaining time is now live on the BYJU'S exam prep app. So you can enroll to this course, get live classes if you want. You have recorded lectures also, study material, mock test, practices, everything. Okay, a fast track revision course along with lots of question practice. For any more details about the course, directly contact 924-133-666. 924-133-666. Yeah. I'll send yesterday's PDF also, Dreamer. Have that in mind. Okay guys, and yeah, in case you want to enroll for the courses and want some financial assistance, so just prove yourself on this Sunday, the 1st October, okay, starting from 9 a.m. there is a national scholarship test. Prove yourself. Based on your performance, you can get as much as up to 90% scholarship on the preparation programs, on the fees of the preparation programs you want to enroll for. Okay, that's it guys. Thank you. Stay safe. Take care. Next subject next week will be control system. We'll discuss the previous questions of control systems. Again, one particular day electronics, one particular day electrical. Okay, we'll keep discussing. Bye bye. Thank you. Stay safe and take care of yourself.